So in the demo, basically we are going to see what is big data, why big data, okay, why big data is ruling the market, okay, and what is the roadmap of big data, and big data, how it's different from other technologies, other distributed technologies, okay. Is the big data is really 100% very stable technology? What is the drawbacks it has? What is the advantages it has? Okay, what kind of applications where big data can fit really in the real-time business scenarios, business use cases, what kind of projects big data can be applied. So we are going to see many things here, okay. So before going to presentation, let me start discussion with small use case, okay. So let's take some small scenario, friends. For example, let's take some bank. Let me take some ICICI Bank. So assume a customer went to ICICI Bank, okay, and the customer requested for 1 year bank statement. He requested for 1 year bank statement. Customer requested for 1 year bank statement. So what the representative will do? Okay, simply he will log into the customer account, he will take the printout and he will give the customer. So maximum the service request time is maximum 5 minutes to get the statement, right? 1 year statement, it won't take much time to fulfill the service request. Now assume if the same customer again went to bank. This time he requested for some 15 years bank statement or some 20 years or 10 years bank statement. Okay, so in this case, the same representative, he will say, sir, you are requesting for historical transactional data. 15 years means it's a historical transactional data, okay, which I cannot provide you immediately. I need to send this request to backend system. Those guys have to process and send you the statement, okay, hard copy or soft copy, whatever it is. Maybe it will take some 24 to 48 hours of time. He will give some time, right? Because 15 years means they cannot do it immediately. They have to send this request to backend system. That's what happens regularly in the banks. So if you see the reason, and they will charge some amount also for this. If you see the reason, why the difference is, if we see in the first case, the 1 year data, 2 year data, 3 years, 4 years, 5 years, the recent data, it will sit in always in our RDBMS systems. So which can be accessed by our real-time applications. That means the regular web applications or enterprise applications, OLTP applications. So this recent data, it sits on our RDBMS boxes, RDBMS systems, relational database management systems, could be like Oracle or MySQL or DB2 or PostgreSQL. It could be any database, DB2, PostgreSQL or Sybase. It could be any database like this. So we know they can access immediately on the fly and they can provide the statement. But if we go to second case, the historical data like 10 years, 15 years, 20 years, 100 years, that's the complete organizational history or complete customers data, customers historical data, everything, okay, will be maintained in the backend systems, what we are calling data warehouse systems. Data warehouse systems like Teradata, right, Netezza. So these are all the warehouse systems. So still we have many warehouse systems available. So in the second case, this guy has to send request to backend system. So the data warehouse system has to process that request and they has to send the response to customer, which will take minimum some hours of time, maybe at least 2 hours, 3 hours, 4 hours. Okay, but if you come to big data, if you come to big data, irrespective of even this case or this case, it's irrespective of 1 year data or 15 years data or 25 years data or 30 years data, whatever it is, if you send these two requests into big data systems, it can give you less than the time what RDBMS system is doing. So there is no something like this. Even if it is a 1 year, 15 years, how much of amount of data, period of data if you request, it can give even less than what RDBMS system is giving. Why? Because the big data is something it's designed completely using an architecture called parallel processing mechanism. Parallel processing mechanism. So it is a core framework, core architecture of the big data. That means it processes the things in parallel. I will talk more about this. Okay. So again, friends, this parallel processing mechanism is something is not newly invented in big data. This is a mechanism designed by Google in 2000s, in the early of 2000s. Okay, the Google is a founder of this mechanism. And later, after Google, right, many companies has been adopted the same mechanism in their applications, in their products, like IBM, Microsoft, Oracle. Many big guys, they adopted the same mechanism in their products and applications. That's what we say Oracle parallel server. Even Teradata also integrated recently. So big data also adopted it in a very optimized way in their framework. So what is this parallel processing mechanism? It's nothing, guys, to make it in a simple word, maybe simple sentence at this time, okay, because in detail we'll discuss in the classes. Suppose I have some employee data. Assume I have some 1 lakh records. So I have this employee table available in RDBMS. If I run a query on this table, something select star from employee, okay, something select star from employee somewhere, country equal to some India or something, whatever it is. I wrote some query. So if we run this query on this table in databases, how it's going to run? It's going to load the 1 lakh table, records one by one, and it's going to check the country column, and it's going to return it. If it matches, it's going to return the data. So it's going to process this 1 lakh records here one by one. That's why we call this RDBMS system called the sequential processing mechanism. Sequential, they do follow sequential processing, record by record. If you go to ETL systems, some of the ETL systems follow sequential, but now most of the ETL systems are also following parallel processing mechanism. They also do the thing same, but they have some other drawbacks we'll see in the coming points. Coming to even big data system, okay. So what this parallel processing mechanism does means, suppose I have employee.data, now assume this is in my big data system. I wrote same query on big data system. So what it will do is, it will divide this file into, okay, I'm telling in short, it's going to divide that file into some n number of files. Maybe assume some 10 files, small files, where each file will have some 10,000 records. 10 files, each file have 10,000 records. Now it's going to find the same query on all 10 files in parallel at a time. So the same query, the query is going to find 10 times on all 10 files in parallel. It's going to run. So basically, obviously, definitely, the response time is going to reduce to 10 times, right? So whatever it's taking here in RDBMS systems, okay, coming to big data system, it's going to reduce to 10 times because it's split it into 10 for small files and it's processing the same query on 10 small files at the same time. Okay, so 10 even not 10 times, it's going to reduce even very more. To say right, it may reduce some 50 times, 100 times even compared to RDBMS systems. And big data, right, is okay. I'll come to that point. So this mechanism, I mean this characteristic parallel processing mechanism, this is one of the core and important feature playing the important role in big data success. And next is the scalability, guys. Scalability in terms, okay. So suppose let's take RDBMS systems, databases. So we know the reason why these are data warehouse systems came into picture in the real time. The reason is since the storage limitations in the databases. That means we know the database servers, we have storage limitations. They can store only particular amount of data, like maybe maximum some terabytes. Suppose if I take Oracle server can store maximum, the two high-end Oracle server can store maximum 16 TB of the data. 16 TB of the data. 16 TB, guys, it is very huge. If you think from RDBMS perspective, if you think from database perspective, 16 TB is very, very huge data. But if you think from distributed application perspective, distributed databases perspective, 16 TB is okay. It's not very big, it's not very small. It's okay. Because the distributed systems are designed to handle even more volumes of data. So we know sometimes these databases, not sometimes, these databases, okay, at one time they will get full. So when the databases are getting full, what they do, suppose Oracle, my database 16 TB, right, some 15.5 TB is full. So immediately some alerts will go to DBA, database administration, some notifications, it will go to DBA. So DBA, what he has to do, either he has to buy one more DB server, that is very costly process. Otherwise he has to add some extra storage for the existing servers, that is also can be done. Otherwise what normally, regularly, currently what they do is, they will move some of the data what is available, some old data, they will archive into data warehouse systems. So they will free some of the space. They will move some of the old data to ETL systems. That's what they do normally. Coming to warehouse systems, right? Okay. Why I'm comparing these things, right? If I compare, it will be easy for you to understand because we know most of us are very comfort with DBA, any one of the databases, at least one or two. Data warehouse systems, don't worry. Okay. I will talk about that here. Coming to data warehouse systems, like in data warehouse systems, we also call them as ETL systems. Okay, ETL systems. So, first of all, the data warehouse systems, okay, they will run on clusters, friends. So, what is a cluster? Cluster is nothing but it's a group of nodes or computers, whatever we talk. Group of nodes or computers, they connected each other in a network. Where all these nodes can talk with each other. That means they can communicate with each other and they can exchange data with each other. So here when I say node is nothing but like a computer, guys. It's like a, maybe not a computer I say, it's like a hard disk, CPU cabinet. Okay. So in our homes, how do we have CPU cabinets? Like a CPU cabinet have its own hardware, hard disk, motherboard, buffer, RAM, processor, everything. Every node has its own hardware. They all will be connected in a network through the network cables in a LAN. So basically this is what we say clusters. So the clusters basically runs with the default architecture, that is master slave architecture. That means there will be one master system, one or more master systems, multiple masters. We'll see in Hadoop, okay, how the multiple master architecture looks like. We'll have definitely minimum one master and remaining all the slave systems. That means this is a master. And these are all the slaves. This is slave 1. This is slave 2. This is slave 3. This is slave 4. Okay. So assume this is a 5-node cluster, right? Now it looks like 5-node cluster with one master, 4 slaves. Okay. So assume the master system, I have some storage. Hard disk is some 2 TB hard disk. And slaves, I have 1 TB hard disk. Every slave has 1 TB hard disk. Every slave has 1 TB hard disk. So this is totally 6 TB cluster. 5 nodes. Total capacity of the cluster is 6 TB storage. So same situation here. Assume one day the 6 TB cluster is full. That means all the nodes, the storage is full. Maybe around 5.5, 5.8 is full. So assume this is a ETL cluster. Maybe we can say it's a Teradata cluster. Assume. So the admin, the warehouse admin, the ETL admin, what he do if the cluster is full? He will also get some alerts. What he will do? Simply, he will add new nodes to the network. He will purchase some new nodes, and he will add to the network. Sorry, he will add to the network. Simple process. He can add the nodes like this, how many he wants in the cluster. Like this, he can add hundreds, thousands of nodes to the clusters. But the problem, what is the Teradata system is facing here when adding new nodes? Basically, guys, concentrate please. So these ETL systems, data warehouse systems, basically what kind of applications we do design? We do design basically batch applications on the ETL systems. Batch applications means batch jobs which are the automated and the scheduled jobs. That means they will be triggered automatically based on the scheduling times. And these batch applications, right, they will run without any manual intervention. They are all more automated process. These batch applications, right, they will run for hours and hours, friends. Okay, they will run for 4 hours, 5 hours, 8 hours, 10 hours. Some applications will run 24/7. If you go to some domains like banking, telecom, right, they do design insurance, they do design batch applications that will run for days even. There it will run even for days. So all this, the problem here is when batch applications are running, okay, since they will run for long hours, right? If something, if they get any issue like with this, some storage is full, something, admin can add new nodes. Okay, admin can add new nodes, but the problem here is when adding new nodes, he has to restart some components in the master system. He has to restart some services in master system. But if we do restart, right, it is going to impact the applications. So basically what he has to do, normally currently what they do is, they have to check for some off time. They have to check for some off time where no batch application is running. And then they have to schedule this, restart the activities, then only the master will detect that new nodes and it can start utilizing the new nodes as part of the cluster. Otherwise, the other way is normally what they do is they will send notification to the entire teams a week ahead saying that, boss, we are planning for so and so activity on so and so day and so time. So make sure no applications are running on the cluster. Even if there is any batch jobs, make them off, so that we'll do some restart service for maybe some half an hour, 1 hour. There will be some downtime. So that's why they have some limitations in scalability wise. But if you go to Hadoop, Hadoop is designed mainly, Hadoop is more scalable architecture, and Hadoop systems, we call them as, they are linear scalable, also we call them as horizontal scalable systems. See the similar scenario. Why said all these things, right guys? Because Hadoop also runs on the clusters. Same architecture, master-slave architecture. Hadoop will have the master system, Hadoop runs on the cluster, it will have master, slaves, the master-slave architecture. So assume now, this is a Hadoop cluster, same 2 TB master, 1 TB slave, 6 TB. So now instead of batch application, some Hadoop application is running. So same situation, I got 6 TB full. So what Hadoop admin will do, he will also add new nodes to the network. But Hadoop master, right friends, it has the intelligence. Hadoop master architecture, the framework has intelligence. Okay, if some new nodes are added to the network without a single click or single command, basically without admin involvement, it has the intelligence. Hadoop master has the intelligence. Dynamically on the fly, it can detect the nodes that is being added as part of the cluster. On the fly, it will detect the node that is being added to the network and it will start utilizing it. Admin don't need to do anything. Admin don't need to do some restarting activities. He don't need to do any click commands or nothing. Nothing is required. Admin even don't need to log in. The master architecture, the Hadoop architecture itself has that intelligence. Dynamically, it will detect the nodes that is being added to the network and it will start utilizing them. So it's not going to impact the applications that is running on the cluster. That is very, very good feature actually. And Hadoop supports also the clusters of sizes thousands and thousands of nodes. The biggest cluster running on Hadoop is by Yahoo, that is running more than 45,000 nodes. Even Facebook is running a biggest cluster. It's around 32,000, 33,000 nodes, I guess. Okay. So because every year they keep on adding new nodes to these clusters. Even Facebook is running, many companies, eBay is running, Amazon is running. So a lot of many companies are running clusters on big data, I mean on Hadoop. So that's why we say Hadoop is more scalable architecture. And next is hardware failures. So let me know guys if you have any questions, something is not clear. Okay, don't hesitate. Okay, so hardware failures. Suppose let's take RDBMS box guys again, go back. Suppose if my database is down. Suppose suddenly my database, Oracle or MySQL, some database is down when applications are running. So what is going to happen? All my OLTP applications, that means online transaction applications, that is web applications, mobile, maybe mobile applications, whatever the applications is dependent on this standalone or maybe enterprise applications, whatever applications is dependent on this database box, all are going to be down. So we know in real time if the applications are got down, how far it's going to impact the customer. It's going to impact the customer in revenue wise, fame wise, lot of things. Recently it happened, many sites. Flipkart is down for a couple of hours recently just because of what is that, backend system is down. They lost some good number of millions in that couple of hours because of that site down. Even Jet Airways, Air India site was down for say recently just because of the backend system down. So it's going to impact many ways if the database is down, but right now the DB architectures are also very advanced. They are maintaining the backup servers. If main database server is down, the backup server is going to play active role. what we call active passive architecture. They do maintain multiple DB servers, the backup servers. We call it as failover servers. Failover servers. The failover servers will take care if there is some issue with the main server. But unfortunately, assume both the servers, the main DB server and the backup server, both are down at the same time. The worst case. There is no option at all. The application should be go down. It's going to impact many ways, guys, to the customers. Okay, definitely. So come to ETL systems. For example, ETL systems, consider it. So one batch application is running. So maybe this is running from last 2 hours. Okay, and the application is almost some 80% of the processing is completed. Okay, some ETL application. So suddenly in the cluster, this situation, one node is down, one node is failed. Node is failed means the node is dead because of different reasons. There are 100 reasons why a node will fail. We'll see it later. Maybe due to some power issue or some hardware issue or some network issue. Okay, the node is down something. So now this application needs some data from this node to finish remaining 20%. So what the application will do, it will try to connect, but this node is out of network. It's not in network now, it's dead. It will try. It will try for some time and it will go down. So what is the problem? All the last 2 hours, whatever is computed and utilized the resources, everything will be lost. Again, admin has to, ETL admin has to fix this. He has to restart the application, which will again take some 2 to 3 hours. Why? Because these batch applications are very important, guys, because they will generate reports. These reports, the batch reports, the reports are very important for for business analysts. Okay, for top management, maybe management team, they will get these reports time to time. Based on these reports, right, they will plan the many of the business activities. If something is lost, maybe it may delay it, right? May have some impact, definitely. Suppose if we assume this is a Hadoop cluster right now, same situation. This is Hadoop application, assume. Instead of batch application, assume that is Hadoop application. Same scenario, so same Hadoop application, maybe not 2 hours, maybe running from last 30 minutes or 40 minutes. Some 80% is completed. Similar situation, suddenly one node is failed in the cluster, not one node. 2 nodes are failed, 3 nodes are failed. Of course, there is a limitation. There is a limit. Nodes are failing. This application needs some data from the failed nodes to complete the remaining 20%. Again, in this situation as well, the Hadoop master has the intelligence. Even if the applications are dependent on the data available on the failed nodes, it cannot access the data, but still the application, the framework is going to make sure the applications will get successfully executed and get the results generated without any impact using a feature called replication. Very, very powerful feature in Hadoop. Okay, this is now implemented in the ETL systems as well. Teradata, it's been implemented, but they use different term from that. Okay, so replication is nothing but redundancy. There will be duplication of data. And again, guys, when I say duplication, it's not going to maintain all this data duplicate copy in the master system. It's going to maintain somewhere in the cluster only. But how it's going to handle the replication, how it's going to handle the real hardware failures, we'll see in detail in the classes. But any kind of hardware failures, Hadoop can handle very gracefully. That's why Hadoop, we say, okay, if we say it's a high available system, that means there will be very less chances of the downtime. So we say it's a high available architecture again. So replication is very, very powerful feature, guys, that helps the Hadoop to handle hardware failures. And next is the cost. When it comes to cost, suppose if you go for the DBs, databases, actually purchasing the DB server is not a big cost. Okay, setting the DB cost maybe something maybe 1 lakh, 2 lakh, 3 lakh, something is fine. But maintenance, every year the customers, the client has to pay for renewals and support some good amount every year. Okay, that is actually huge burden, but even that is okay if you go for DBs comparing to ETL systems. ETL systems, right, we don't need to say because they are very, very, very costlier, guys. They are very, very costlier systems. The reason is they are designed to run on high-end hardware models. So they need very high-end hardware configurations and high-end hardware models, like they need 32 GB RAMs, 64 GB RAMs, they need high-end processors, high-end hardware models, high-end hardware configurations. And just even the ETL applications, the software, the licenses are very costlier. In my experience in the last 4-5 years, I see the customers who are running on the ETL systems, right, they are paying between $250K to $300K every year just for licenses and support. Just only for licenses and support they do pay for these ETL guys. ETL, who is that? These systems. And cluster setup cost even still more costlier. But when it comes to Hadoop, it's so cheap. Why reason is Hadoop is designed to run on commodity hardware. Commodity hardware, when I say it's a cheap hardware, friends. It's a cheap hardware. Hadoop don't have any hardware limitations. It can run on any kind of hardware models, any kind of hardware configurations. Okay, for example, to make it more simple, for example, to process 1 TB data, okay, on Teradata cluster, it's going to cost around $16,000 for the customer. If I want to process same 1 TB data on Hadoop cluster, it's going to cost around $3,000. So you can see the cost difference there. It's even less than 5 times cheaper. The reason is because it's a commodity hardware. See something, you are getting 5 times cheap means definitely you try that, right? So cost wise Hadoop is very, very, and to say right, real time, why most of the applications are migrating to Hadoop is because of mainly these 2 reasons: hardware failures and the cost. Because any client expects 2 things. First is he wants his cluster should be 100% available, less downtime, and second is, of course, the cost. He wants to be as cheap as possible. That is the reason most of the mainframe projects are migrated to Hadoop, and still many of the projects are in migration stage to big data, mainframe projects. So along with the mainframe projects, even the ETL systems, the Teradata, definitely one day already mainframes is going to maybe phase out. Phase out means most of the projects almost all the projects is going to migrate to Hadoop. Already some are done, some are in process, because migrating to mainframe is not done, cannot be done in 1 month or 2 months, because they invested huge cost on mainframe systems from 1970s, 1980s. So it will take some time, but the process is started. It's already moving very well. Even the ETL systems are moving, because if you see this much cost difference, definitely they will make an attempt. If everything goes smooth, if the ETL systems are also done, then in future RDBMS systems also will be more migrated. Already it's been started. Some projects it's been done already. They are using big data Hadoop in place of RDBMS systems, but still achieving complete RDBMS principles and rules in big data is not yet there. Okay, because RDBMS is most compliance to ACID rules, normalization, a lot of things is there, right? In big data still some are lacking, so they are working on that. That's why I'm saying maybe in the near future, maybe 3 years, 4 years, things get settled down, then even we don't know they are going to replace big DB RDBMS systems. If there is a thing, right, then it's going to be still very big revolution in big data. Okay, so these are the some important, and next is again size of data. So big data can handle any size of data, guys, like it can handle GBs, gigabytes, terabytes, petabytes. It can handle what is it? Petabytes, exabytes. It can handle zettabytes. It can handle utabytes. Okay, what I mean is, 1000 GB is 1 TB, 1000 TB is 1 TB, 1000 TB 1 EB, 1000 TB 1 GB, ZB, 1000 ZB is 1 YB, utabytes. Of course, we don't have any organizations handles the data in utabytes, but there are companies handling data in exabytes, like Google, Facebook. Okay, some big guys are handling data in exabytes. So Hadoop can handle any volumes of data. Right now there is no limitation at there. The next is type of data, very important again. So in our experience, maybe in academics or maybe in our experience, real-time experience, so we work till now mostly with the RDBMS systems, right, databases. So what type of data normally the databases is going to handle? It's completely relational data. Relational data means it's structured data, right? Everything, schemas will be defined, then data will be loaded, we'll do all operations on top of it. But if you go to real time, okay, the real data in the world, okay, if you take the complete data available in the world, right, we know how much percentage is the structured data. The percentage of the structured data is just only 20%. So 20% is only the structured data what is we are maintaining RDBMS systems, and the remaining 80% of the data is in unstructured format. Unstructured format without any schemas or something, raw format, which could be in flat files or different formats, available in different archives, storage disks. So processing this unstructured data is very challenging. I mean, we have some tools for that, traditional tools, but they have some drawbacks as well as they are licensed tools. Because Hadoop is mainly for data analytics case. Data analytics means it's not mainly on structured data. It has to be on structured data as well as unstructured data. Because this is the data which plays important role in data analytics. Of course, this as well, but this is. So this data again, this unstructured data which is 80%, right, among that we are using only some, we are processing only some 5 to 6%. Remaining data is always in archives. Nothing, if you take some 1930s, 1940s, 50s, 60s, 70 periods of data, we may not use it more frequently, right? It will be in archives only mostly. If you process, we process mostly the last 10 years data, very frequently. So this is very important data where Hadoop has solution to process any type of data, guys. To process any type of data, to process structured data, unstructured data, semi-structured data. And if you ask me why this much of volumes of unstructured data, because it's nothing, the sources available in the world who are generating unstructured data is very huge. There are n number of sources that is generates the data only in unstructured format. For example, satellite data, GPS data, sensor data, military surveillance data, geological data, okay, social networking data, blogs, videos, graphs, images, call center data. So if you see, right, this data mostly will be in unstructured format. Again, in unstructured format, they could be in different formats. Like it could be in text format, it could be in binary format, it could be in some XML format, it could be in whatever JSON format, it could be in some compressed formats. So analyzing these types of data, these volumes of data is very tough and challenging job. Even Hadoop also, the developers mainly, the challenging job in Hadoop is mainly while understanding. Basically understanding is very important. If you could understand, developing solution is not a big thing in Hadoop. Hadoop can process any type of data, guys. Semi-structured means basically XMLs and JSON files. Okay. So this is one thing, and last but not least is application dev time. So as I said, mainly Hadoop is mainly for data analytics, friends. Hadoop is mainly for data analytics. So analytics, we have again different types of analytics. We have batch analytics and we have real-time analytics. Batch analytics is what the ETL systems are doing already, but Hadoop can do it in even better way with less cost and with achieving all these features, scalability, hardware failures. Real-time analytics, Hadoop can do it. We say it's a OLAP, online analytical processing systems. And this is where the competition is going between in the market, because real-time analytics is very important. Analyzing the data on the fly dynamically on the volumes of data is should be very fast. So for example, if you want me to explain some use case, let's take some e-commerce sites. Let's take some maybe eBay. So assume a customer went to eBay site and he started searching for some phone, maybe something like iPhone, okay, something, some iPhone 5s or 6 or something. So he started searching for phone. So what happens if we search for phone and press enter, what it will do, it will take the request to some, normally our regular applications, traditional applications, what it will, the request will go to some middleware system, maybe some application server, there some component will run, it will send the request to database will send that iPhone 5s data, the query result, and it's going to send the query result back to eBay site, it will list that iPhone 5s, what are the models available. But this is not what expected from big data systems, guys. So if the same request, the search request, whatever you do, if you send to Hadoop cluster, Hadoop will do some recommendation analysis. Maybe you guys some observed, if you go to any e-commerce site, something, if you search for something, after a couple of minutes, after a couple of seconds, maybe after 10-20 seconds, you will get some bars, left side, right side, saying that, boss, you are looking for iPhone 5s, but we have this many phones. Maybe you can have a look with the similar features or better features, maybe within the less cost, maybe with better ratings, better reviews, better warranty or whatever it is. You can look all these phones. It's going to recommend to the customer. It's going to help the customer to choose the best product. So you can have a look on these models as well. Still, if you stick for iPhone 5s, okay, we have this many vendors is there. So who are providing with different service periods, different warranty periods, you can maybe select one. So doing this recommendation is not like our regular application, because it has to compare, it has to analyze with lot of mobile models, their features, their ratings, reviews, prices, everything, configurations, feature, everything. So it will take a lot of time. So it has to be done very fast. It has to be done very fast. because customer will not wait for a long time. If he will see for 1 or 2 minutes, if he don't get for some related product, any something what he is looking for, he will simply move to some other site. So analyzing these volumes of data is not simple as like our batch analysis or something. It should be done very fast. So that's why Hadoop is being used in most of the e-commerce sites. Not only e-commerce, in most of the domains, okay, there are different use cases. I will show you in the presentation. So again, to do this analytics, okay, to do this analytics, Hadoop has n number of solutions, guys. So Hadoop again is not a single solution technology. It has a multi-solution technology. So if you want to apply analytics in big data, we can do the analytics. We can implement the analytics using MapReduce. This is one framework. We can implement using Pig. Pig is one framework. We can do it with Hive. Hive is one framework. We can do with HBase. We can do with Cassandra. We can do it Impala. We can do it Scala. We can do it Star. We can do it Spark. We can do it MongoDB. We can do it Kites. We can do it what is that? Cascading. We can do it like this. There are many. These are all the frameworks. These are all the solutions. So if you want to do some analytics, right, you can do in MapReduce, you can do in Pig, you can do Hive. So that's why there are multiple options, multiple alternatives available here. So we can choose any one. We can choose any one or some combinations while doing the analytics. So there are more options available, and the good thing here is all of them are open source. Most of them are open source, not all. Most of them are open source. And one more good thing is, except MapReduce, learning the remaining ecosystems, okay, not remaining, most of the ecosystems. Learning most of the ecosystems, we don't need any pre-technology experience or pre-programming experience. Even a fresher, even an experienced guy, they have to spend same efforts to learn them, because every ecosystem has its own framework, has its own advantages and disadvantages, and every ecosystem has very powerful engine, guys, has its own powerful engine. So without any pre-technology experience, we can do all these things, because one more good thing, yeah, learning these ecosystems also won't take much time. Some ecosystems are very simpler. Some ecosystems, of course, they are complex. So if you take Pig, right, Pig has hardly some 20 commands. If you learn these 20 commands, how to apply when you are doing the analysis data analytics implementation, you can do anything in Pig. If you know SQL already, right, then you can straight away do programming in Hive. Hive follows same SQL syntax, SQL queries. Hive, Impala, even Cassandra. Come to HBase. HBase, of course, it's a little complex in terms of architecture, but very beautiful architecture in HBase, Cassandra. So everybody has to spend same efforts on this, but when do we need some language, maybe like Java or Python or something? If project management decided they want to do data analytics in MapReduce, they want to use MapReduce, then must and should we have to know one programming language, friends. Again, MapReduce is not limited for Java, guys. MapReduce programming we can do in C++, we can do in Python, we can do in Java, we can do in Ruby, we can do in Perl, we can do in Shell, we can do in any scripting language. But since we know Java is more popular and Python, so in real time they use either Java or Python for MapReduce programming. And again, when I say Java, in our course we are going to deal the MapReduce programming with Java only. Again, when I say Java, for MapReduce we need to know only core Java. Core Java is only required for MapReduce programming. We don't need to know advanced Java. Advanced Java is not supported in MapReduce. I mean, it's not required for MapReduce. But we should be strong in core Java. Again, in core Java, when I say here RMI is not supported, socket programming, network programming, nothing will be there. Even threading also is not required. You should be very strong with the OOPS concepts and capture. I mean, the basic OOPS concepts, inheritance, polymorphism, how to do programming, and all the OOPS features. Also, we should be very strong in the Java collections. So, if you know that, then we can do in MapReduce. So, in our course, we have some 6 classes on core Java, both theory and practical. I'll be taking that before going for MR practicals. Also, I'll be taking one class on Unix basics. Okay, so you don't need to worry about that. But if you go to real time, most of the projects, even if it is if they started with MapReduce, finally they will end up doing the same development again in the ecosystems, because ecosystems, right, they are easy to do development, they are fast to do development, they are easy to do code maintenance, code debugging, they are very efficient and effective. Even is the reason if you go for any Hadoop project, they will start with proof of concept. Proof of concept is like a pilot project. Why? Because is choosing which one to use for development is a big headache in Hadoop. That's where Hadoop architects play important role. They will try some 2 to 3 solutions. They will try the POC, proof of concept. They will try with some 2 to 3 ecosystems, and they will see which is good. That's why I said everything has its own advantages and disadvantages. Even by end of the course, maybe by the time you start job trials, you should be strong at least minimum 3 ecosystems. You should be very strong, minimum 3 ecosystems. If you know 3 ecosystems, learning the others is not a big thing. Maybe 2 to 3 days learning the new things. Okay, because the base is same. Only you have to learn some APIs. Okay, so here, what is it? Yeah, POCs also we started with some 2 to 3 ecosystems. They will do lot of comparison, the performance comparison, implementation comparison, complexity comparison. Then they'll choose maybe 1 or 2 ecosystems for the actual development. Even the projects also never be implemented with 1 ecosystem. They will, so I'm telling, right? So except MapReduce, all these things we call them ecosystems, guys. Okay, we call them ecosystems. Even project implementation also they will do with some 2 to 3 ecosystems minimum, because at one case, I mean at one module, maybe some particular data cleaning or data filtering, pig is best. If there is something kind of querying, then Hive is best. If there is something called real-time analysis you want to do in Hadoop, then HBase is good. So everything has its own uniqueness as well as, but you can do everything in every ecosystem. Okay, but since all are open source, you can use anything at anywhere. Okay, no problem at all. So MapReduce, if we go to real time, I said some 30 to 40% projects will use MapReduce, but 60 to 70% projects they will go with the ecosystems. Even the guys who started with MapReduce, definitely one day they will redevelop again with the ecosystems, because ecosystems are very smart, easy to development, fast to development. Suppose if I write some functionality in MapReduce, okay, so in MapReduce I write 1000 lines of code. I will talk about that, Usha. I will show you the course curriculum. Okay, I wrote some 1000 lines of code in MapReduce. If I rewrite same in the ecosystems, right? If I go to Pig, if I write same functionality in Pig it's going to then maximum 150 lines is also more. If I do same functionality in Pig, if I do in Hive, even it will be less. Maybe it will be around 80-70 lines of code. So the development will be very fast, because analytics means the functionalities, I mean the requirements keeps on changing day to day. So the development should be very strong, very fast, because the customers who do this analysis very fast and comes with better services in the market, they will gain more market. And I am betting, guys, data analytics has very bright future. It's going to rule the market. because whatever we have to do, it's already done on database perspectives. RDBMS and the middleware technologies all got stable. There is nothing new there newly need to be invented. So that is the reason how technology is running around the distributed systems, mainly on data analytics. Okay, and 2015, right, specifically has very vast market for big data. Recently, many articles, NASCOM, India, so most of the level 3, level 4 companies are migrating to big data. They are starting the practice teams. Even if they don't want big data in the project, they are starting practice, at least to understand why big data and is it really going to help them in their projects. Because everybody is following, they have to follow. And I see in the last just 1.5 years, 2 years, I see many startup companies are built or started on big data basically to build products on big data. If you go to US, right, we don't need to say. Hadoop has very vast market in the US. Even the PACE, I'll come to that, okay, PACE sector later. So this is like the ecosystems, guys. So I will show the course curriculum, what we are going to cover. And we have still some more ecosystems. So let's go to presentation. So any questions here? If not, I'll jump to presentation. So yes, I'm recording it. Yeah, fine. So let's see the presentation. So this is about myself. You can skip that. So this is the statistics given by international data centers saying that how fast the data is growing, guys. So in 2009, the total data available in the world is 8 lakh petabytes, and they are saying by 2020 it's going to reach 35 gigabytes, that is 35 billion terabytes, which is 44 times more. So these volumes of data, what is being generated, that is in petabytes and exabytes, right? Before days they used to archive. But nowadays it's not like that. Companies want to use every piece of information that is being generated as part of the organization. They want to use some analysis. They want to analyze and process the data, and they want to come up with some beautiful, some good results, some that will help them in different ways. Simply, they cannot discard the data. They have to analyze the data. This analysis will help them in many ways for taking certain business decisions, to come up with new strategies, business strategies. Okay, to increase their revenue, to give better services. Okay, to increase their customer count, to give competition for competitors. So data analytics is going to help the companies in many ways. So to do data analytics, basically first we should be able to understand the data, what type of data are we dealing with, what kind of format it is. We need good storage structure to store the data. I mean, we need good database kind of system to store this data, and we need good processing framework to implement the analytics and to run this analytics on top of this data. So we have a lot of frameworks available in big data, and of course we need good cluster setup, good network infrastructure, cluster setup, and these things are all expensive, guys, with the traditional systems. The traditional systems, they are expensive, they follow sequential processing, which is time taking. Because of that, the response will be slow and delayed, and they do face mainly the network issues. So the alternative came into market as a big data. Okay. So this is how the clusters looks like in real time. Okay, I will talk more about this in the coming classes, the architectures. So big data can apply in many of the, again coming to analytics, right, we have different categories in analytics, guys. We have predictive analytics, we have sentimental analytics, we have recommendation analytics, we have social networking, social analytics. We have feedback analytics. Okay, there are different categories of analytics where we are going to deal some of the use cases in these categories in the course. Okay, like forecasting the coming year sales based on the previous year sales reports, calculating the probability that a server may fail in the coming 6 months, and analyzing the factors why a server is failing so frequently in the last 6 months, or last 1 year, performing the clickstream analysis of the company website. So we are going to deal some of the use cases. We do analyze, design, okay, the use cases. So again in Hadoop, right, what is that? We have ecosystems, right? The ecosystems has, as I said, every ecosystem has its own framework. So some ecosystems, I mean, we say them NoSQL databases. Some ecosystems use something called in-memory mechanism while processing the data. Some ecosystems use that file system. We say it's Hadoop distributed file system, HDFS, to store the data and process the data. And something called big SQL is also there. Okay, I'll talk more about this in the course, guys. Don't worry about that right now. So coming to job market, this is with the current technologies, huge competition for jobs available. But if you go to big data, it's completely reverse. To say fairly, right, industry is struggling to get the big data professionals. You could see, right, I see from last 1 and last 2 years. Okay, for example, in my current company itself, I joined 1 year back. From the 1 year, I mean, we have actually a requirement of 200 people. From last 1 year, we got recruited maximum 40 people is the team now. Still, we have 160 open positions. I mean, 160 not immediately, but plan is like to make it 200 by at least in the next 6 months. Problem is we are again doing the recruitments every alternative weeks, every drives and everything at different locations, but still we are getting people, but we are not able to get the people meeting the expectations. So what we are doing is we are changing our expectations. Okay, we are very strict in starting, but now we are little liberal. That means, okay, if a guy knows Hadoop, he is strong in theory, let him gain. We'll make him training again. We'll get him trained and we'll assign to a project. So that not only this, my company, many companies, they are facing very tough job getting Hadoop provisions. That is the reason, right? Most of the Hadoop projects are going for outsourcing, for even from some good companies. Okay, even if they have people, okay, since the competency is not there, the projects are going for outsourcing. So there is very good market, guys, and some companies what they are doing is they are providing trainings directly from Cloudera, Hortonworks, and they are assigning to projects. Okay, internal trainings. So there is very good market here, and along with the market, even the expecting more jobs in 2014 is done. Okay, 2015 we have again, actually 2015 we thought it's even more than what we expect. The market is very huge market is there, and US especially has big market. So it's saying it's going to lack big data professionals in 2015 and 16. And coming to compensation as well, US has very good compensation providing for big data professionals. I mean, if you are good, at least minimum 3 ecosystems in Hadoop, right? You can expect minimum. I mean, the pace what they are doing. I mean, what I see in my circle, in my network, and with my students, and what they are getting paid is they are getting paid between $100 to $180 per hour. And they are getting paid between 130K to 250K. 250K, recently one of my students in UK got placed for 250K. Actually, he is even less experienced than me, but he got very good pay. 250K is not small. Okay, but I mean there are people caught for 190K, 120K like this, but there is very huge market. India also the compensations are good, guys. I mean what I say is, I don't say Hadoop has very good, very heavy packages, but comparing to other technologies, definitely Hadoop has some more edge. It will get slightly greater only. Okay. So coming to big data, so big data basically is not a framework, it's not a technology, it's a methodology. Big data is a methodology basically, it's built to build, it's a big data is a methodology designed to build to build distributed applications that runs on the commodity hardware and can handle volumes of data, okay, that runs on clusters, and it should able to process this data in less response time. Okay, it's a basically methodology. It's a define some standards how to build distributed applications. So following the standards, Hadoop is a framework design. So normally we say big data and Hadoop both are same only. Okay, but big data is just a methodology. So in big data, there is a rule called 3 V's: variety, velocity, and volume. So any big data application should fulfill this 3 V rule. That means any big data application should process any variety of data. That means structured data, semi-structured data, unstructured data, and it should process any kind of analytics, batch analytics, real-time analytics, and it should follow any volumes of data. That means it should be able to process any volumes of data like terabytes, petabytes, exabytes, zettabytes. Okay, so we'll talk in detail about the 3 V's and these differences again in the first class of the course. So the volumes of data we do get generate from web domain, e-commerce domain, shopping, banking, retail, telecom. Okay, data will be in different formats again, structured and unstructured. So this data plays important role, guys, for data analytics comparing to structured data. So in our course we are going to do some image analytics. Okay. We are going to do image analysis, some scenarios, some use cases we are going to design and do the coding as well. For example, let's take Facebook. In Facebook, in my account I uploaded one image file, some image file. But the same image file has been uploaded by some different account holders in the Facebook, okay, in their accounts. Assume some 1,000 guys uploaded the same photo. Then is the Facebook is going to maintain 1,000 copies of the same image? No. Is it going to maintain the 1,000 copies of the same image means? No. It is going to manage only one copy with 1,000 references. But how it's going to do this image management? We'll see in the we'll see in the use case when we are doing that. And then also we'll deal with the use cases to scan the image and see what kind of object is there in the image. Is it some scenic image or some person image or some animal image? What kind of image is there in the image? We'll do some image scanning analysis. And also we'll do some text analytics like the feedback analytics, recommendation analytics, that is following by the LinkedIn, Facebook, the social networking sites, how they do the recommendations. And again, coming to Hadoop, guys, we have different Hadoops available in the market. This is one more thing. So it will take maximum 5 to 10 minutes, guys, but it will be interesting. So please be patient. So and again, in Hadoop, we have different Hadoops are available, guys. So to understand why this many Hadoops, what we need to learn, we need to start with the history of Hadoop. Okay, so just please concentrate. So a person called Dow Corting, he is the father of Hadoop. Okay, he started a project called Nutch in 2002. Okay, the aim of the project is to build a search engine on distributed systems. He wants to build a search engine on distributed systems. So while he implementing this project, right, what happened is in 2004, Google released two papers called Google File System and Google MapReduce. So actually Google is a inventor of Hadoop framework. Actually they are the origin. Okay, this is again for developing, doing analysis on the framework for doing the data analytics, and it has its own database as well, architecture. So this guy got inspired from these two papers and he implemented the same algorithms in the Nutch project. So he implemented the same Google file system and Google MapReduce principles in Nutch project, and he named them as distributed file system and MR. So this is he is doing in 2005. So while this is doing, Yahoo recruited this guy. He became the employee of Yahoo, and Yahoo taken over this Nutch project. So they took over this Nutch project and renamed it to Hadoop. They renamed it to Hadoop, and they renamed these two components as HDFS and MapReduce. Okay, they renamed them as HDFS and MapReduce. These two are main modules, and Yahoo, after implementing the complete, they gave for release management and support completely. They handed over this Hadoop project to Apache, the open source foundation. So from 2007 to till now, Apache is only managing the complete release management and version management. Version management, support and everything is doing by Apache only. 2015 even now. So Hadoop is open source. So that is, we say this is Apache Hadoop. Apache Hadoop is open source. So this is a core Hadoop. But you could ask, when it's coming 2007, why it's not so popular till 2011 and 12. The reason is, when the initial Hadoop they release it, right, it don't have ecosystems. It has only MapReduce, that also only in Java. No ecosystems is there. So is the reason 2007-8, right, no company shown interest. They thought like it's one more Java based technology and nobody shown much interest towards that. But the Facebook is the first company started using it along with Yahoo. The Hadoop they did MapReduce programming for data analytics. But they found it very complex writing MR programs and doing the analysis on MapReduce. So they designed a wrapper on top of MapReduce called Hive. Hive is designed by Facebook. Same time, okay, Yahoo also designed one wrapper on top of MapReduce as their internal project, that is Pig. So when these two came into market, then Hadoop, okay, it's become easiness, what is that? It's become, when these two ecosystems software came into market in 2008 and 9, I guess, in 2009, then people started looking towards Hadoop, because the Hive and Pig, they are abstractions. They made the development very simpler without knowing anything about MapReduce. So then started using the Hadoop. Later the other ecosystems has been developed one by one. But the thing here is, concentrate guys. So when this is happening, right, in parallel, what happened is the industry big guys like the IBM, okay, Microsoft, Oracle, okay, Amazon, still many guys are there. Mapper, there is a company called Mapper. There are many companies. So what this guy did is in 2000 at the same time around they also, we know that these companies will have R&D teams. So those guys will export technologies. They will see what are the technologies coming into market or how good they are, and is there any way they can achieve some revenue to out of those products or out of those technologies. So they analyzed this Hadoop and they found Hadoop is going to be more feasible and more going to be revolution in the market, whatever it is. What they did is they took this Apache Hadoop, which is open source, right? They build their own products on top of Apache Hadoop, what we call IBM Big Insights. This is IBM Hadoop. They build a wrapper on top of Apache Hadoop. That is IBM Big Insights. Similarly, Microsoft did, but Microsoft they didn't. They took the Apache Hadoop, but they rebuilt completely again the Apache Hadoop using the .NET and C#, and they built their own Hadoop called HD Lights. Okay, and Oracle also used Apache Hadoop. They built a product on top of it, that is Oracle Big Practice. And similarly, Amazon did the same on Apache Hadoop. They did build something called Amazon EMR and S3. And similarly, Mapper also did it, Mapper Hadoop. So like this, we have many Hadoops are available. Okay, I will tell ETL Hadoop, lot of Hadoops are available. So what is the difference between this Apache Hadoop and all this Hadoop? Nothing, guys. The problem in the Apache Hadoop is it's open source. If you want to do development in Apache Hadoop, you don't have any GUI tools for that. You have to depend on our Windows tools, maybe Notepad or Editors or some Eclipse or something. Any IDEs, OS Builder, any normal IDEs or any tools or editors. And again, in doing the installations in the Apache Hadoop, you have to do manually a lot of things, configurations, running commands, configurations, integrations, manual work will be there. So what this guy did is, these smart guys, they took this Apache Hadoop, they automated the installation process, they built some GUIs for development, and they built it as a product, and they made the product, and they made the products as licensed versions. All these are licensed. So HD Lights is licensed, Big Practice is licensed, this is licensed, this is licensed. These are all licensed. Okay, these are all licensed versions. But why these are not much popular is because they are costlier, and they will provide the infrastructure support, cluster support, they will charge for that. These guys are very smart, they know how to market. And what these guys did, right, their customers who are willing migrate to Hadoop from mainframe systems or some ETL systems, they ask them, boss, if you want to use Hadoop, stop there. I will give my Hadoop, you can use it, maybe we'll provide you support if you have any issues. Maybe we can talk on the cost. So they made their customers use their Hadoop. Okay. So that's how they started looting the market, but at the same time when they are doing this, a person founded a company called Cloudera. So what this guy did is, he also built a product on top of Apache Hadoop called Cloudera distribution of Hadoop, and he gave it for completely free. He gave it completely for free of cost. But he is still more smarter. He founded in 2009. He gave for 2 to 3 years free. Once the company got, many of the customers got addicted for that, right? Then he started slowly pricing for this product. But even if he prices, he is more reasonable, guys. He is more